Okay, good morning class. Today our learning objective is how do we calculate percent change, which is increase or decrease. Involving money, time, etc. So we want to look at a few examples including money and time, and if time permits we can do a few more examples in other areas, probably distance also. So alright, so the correction, money. Here's what we do now. Convert the following fraction to a percent. You convert the following fraction to a percent, and the fraction here I'm going to give you is going to be 12 out of 25. Okay, 12 out of 25. Alright, so solution. Like we saw yesterday, you can take 12 out of 25 and literally write it as 12 divided by 25, which becomes 0.48. And then, so that's step one. And then step two, you take 0.48 and you multiply it by 100%. Okay, or in other words, you can move a decimal point 2 places and you just end up getting 48%. Okay, again, if you're converting from a decimal to a percent, you multiply by 100%. All right. Okay, so you should have this written down in your journals by now. We're going to start. Please take out your notebook. Please take out your notebook and start copying the notes. Okay. Please copy solutions only, okay? Please copy solutions only in your notebooks, of course. Okay, so before we go, copy the following. Please copy the following. A percent change. The percent change is a ratio that compares the change in quantity. So it compares the change in quantity to the original amount. Okay. So a percent change is a ratio that compares the change in quantity to the original amount. And in the form of an equation, here is what the percent change say. Okay, so this is what the percent change says the following in terms of an equation. Okay. Equation says the percent of change. Okay, right there should be an off here. Percent of change. Percent of change is equal to amount of change divided by original amount. So the percent of change is the amount of change divided by the original amount. Alright? And in terms of percent of change, we can talk about two types of changes. So let's deal with the first one. Percent of increase. So percent of increase is equal to amount. Percent of increase is amount of increase divided by the original amount. And the percent of decrease. Percent of decrease equals amount of decrease divided by the original amount. Okay. Alright, so by now we should have our learning objective copied. So I'm going to erase everything, and we're going to start with our first I do problem. So first I do problem. I do number 1. So we have these two signs advertising gas. Okay. Two signs advertising gas. So in 1970, we have a gas price of $1.30. Okay, and now in 2010, we see a gas price of $2.95. Alright, and the question that comes to us is find the percent change. Find the percent change in the cost of gasoline from 1970 to 2010. Round to the nearest whole percent if necessary. Okay, so here we have it. So how do you solve these kind of problems? Well, step one, the first thing that you do here, step one is find the amount of the increase. Okay, step one, find the amount of the increase. Find the amount of increase. And the increase here is $2.95 minus $1.30, which gives us $1.65. Okay. And step two is to finally find what we're searching for. Step two is find the percent increase. Find the percent increase using the results above. Okay, so how do we find the percent increase? Well, we know the formula. Percent increase, you should be copying this down. Percent increase is equal to amount of increase divided by original amount. Okay, keep on percent of increase, keep on leaving out the off. So it is the amount of increase over the original amount. Okay, which in this case is going to be equal to, it's going to be equal to $1.65 over $1.30, which you can put in your calculator as just 1.65 divided by 1.30. Okay, which would give you approximately 1.27, which when you convert it to percent, you either multiply by 100 or move the decimal point over 2 places. So that's going to be 127%. Okay, 127%. So the increase was 127% from 1970 to 2010. Okay. Again, let's just run this over. So we were given gas prices from 1970 to and not a gas price at 2010. Gas price in 1970 was $1.30, and the gas price in 2010 was $2.95. And we are told to find the percent change in the cost of gasoline from 1970 to 2010. Round to the nearest whole percent if necessary. Well, we know that this is going to be a percent increase because we have an increase from $1.30 to $2.95. So step one, we find the amount of the increase by subtracting $1.30 from $2.95, and we get $1.65. And step two, we find the percent increase using the result above. Percent of increase is equal to amount of increase over the original amount, right? And what we get is we have $1.65 divided by $1.30, which just becomes the same as 1.65 divided by 1.30, which gives us approximately 1.27, which we convert to percent by moving the decimal point 2 places to the right, or by multiplying by 100. So 1.27 is equal to 1.27 times 100%. You can multiply by 100% without changing the value. And that's where we get 127% from. Okay, that's where we got it from right here. Okay, so that's it. Now we're going to move on to a few more examples. Okay, a few more examples. Okay, so problem number 2, we can work on this together. So we do, and this is problem number 2. So we are told that Yusuf bought a DVD recorder for $280. Now it is on sale. It is on sale for $220. Find the percent of change in the price. And it says round to the nearest whole number. Round to the nearest whole number if necessary. So what do we do here? Is this an increase or a decrease? Okay, we know it's going to be a decrease. So we take the $2, step 1, let's work on the steps first. So step 1, we take the $280 rather, and we subtract the 220 to get $60, and this is the amount of the decrease. Okay, so this, using an arrow here, is the amount of the decrease. So that's what we found first. And then step 2, we're going to use our percent decrease equation. So percent of decrease. Percent of decrease is going to be equal to, percent of decrease is equal to amount of decrease. Okay, so percent of decrease is equal to amount of decrease divided by original amount. And in this case, that would be $60 divided by, what was the original amount? $280, because that's what the original cost. That's what the original cost was. And so this is going to be, we can take 60 and divide it by 280, which would give us approximately 0.21 to 2 decimal places. And again, if you want to convert that to a percent, how do you do it? Well, you literally take a decimal point and move it 2 places to the right, which is the same way as saying you're taking 0.21 and multiplying it by 100%, which would give you 21%. Okay, so it's 21%. So the DVD was decreased by approximately 21%. The DVD was decreased, the DVD recorder was decreased by approximately 21%. Okay? Alright, so you have that now? Okay, I'm going to erase this. Of course, if you're watching by video, I mean on YouTube or in a class, you can always stop the video, pause the video, and go over the thing. Okay. Alright. So now we're going to do another topic called percent error. Okay, percent error. This is still a kind of change. It's a change in what you thought the value of something was, as opposed to what the value actually is. So that change is called a percent error. Okay, so copy, please copy. Please copy. Okay, so the percent error. Okay, the percent error is a ratio. These are all ratios. Is a ratio that compares. Is a ratio that compares the inaccuracy And in equation form, this says that percent error is equal to amount of error divided by the actual amount. So the actual amount is what the actual thing values or weighs or whatever else according to the context of the problem. Okay, so please make sure you copy that. Okay, now suppose here's a question. So I do. Okay, and I think this I do is number 3. I'm going to call this number 3. Okay, so I have a jar. And I have gumballs. All different color gumballs. First, you don't have to copy the gumballs unless you like art and you like to do this. Okay, so I got gumballs. You got the idea. I got gumballs, and I guess that there are 300 gumballs in the jar. So my guess was that, again, this is an error, this is not a subtraction sign. My guess is that there were 300 gumballs. Okay, and when I actually found out the amount of gumballs there were, it came out to 400 gumballs. So we know that the actual amount is 400. So don't forget, the actual amount always go on the numerator. So in order for me to find my percent error, I need to subtract. Okay, so step one is I take 400 minus 300 to get 100, which is my error, which is the amount of my error. So 100 is the amount of error. 100 is the amount of error. And step 2, now I just have to use this information. So the percent error is going to just be equal to the amount of error over the actual amount. Okay, for the actual amount, which is going to be 100 over 400, okay? Which, if we do this, 100 over 400, we get 100 divided by 400, which is just equal to 0.25, which we know as a percent is 25%. We should know that from memory. Okay, so 0.25 is 25%. Okay, so that's our first percent error problem. Look at it, think about it, study it, and see if you understand it. Okay, so we're still in percent error. So let's do another percent error problem. We do. I want you to also think about this one. So we do, and I'm going to call this number 4. Okay. So problem is Ahmed wants to practice free throws. Okay, Ahmed wants to practice free throws. He estimates the distance from the free throw line to the hoop and marks it. He marks it with chalk. Actual distance should be, the actual distance should be 15 feet. Okay. Ahmed's estimate. Ahmed's estimate is 13.5 feet. Ahmed's estimate is 13.5 feet. And the question is, find the percent error. Find the percent error. Okay? Find the percent error. So, the solution, as usual, step 1. Step 1 involves just finding the amount of error. So 15 feet minus 13.5 feet equals 1.5 feet. Okay. And that is the amount of error. Okay, so this here, an error is the amount of error, 1.5 feet. Step 2, I'm going to find the percent error. So percent error is equal to the amount of error divided by the actual amount. Okay, and so what I have here, I have an error of 1.5. Okay, and the actual amount is 15. So 1.5 feet over 15 feet. I drop off the feet because the feet here would cancel the feet there. And as we know, this is the same as 1.5 divided by 15, which we found to be 0.1, okay? Which, if I want to change that to a percent, I can multiply by 100. So that's going to be 0.1 times 100%, which is just going to give me 10%, okay? So the error is 10%. 10% error. Right? So that is the lesson. And you would now go on to do your you-do, which you'll get in the form of a handout or something. So next would be your you-do. Okay? Any questions? All right.